Hey gang, in this video I want to talk about percentiles. In this video I want to talk about percentiles. I'm going to go back for a minute or two and just talk about relative frequency histograms again. But I want to focus on percentiles in this video. So just a quick kind of rundown of what a percentile is. Percent comes from 100, so we're talking about kind of if you think about a score on a test or something, you could get a percent correct. If you think about field goal percentage, if you're talking about something like basketball, it's what percentage of the shots is somebody making, so that's out of 100 again. So here for percentile, we've got a couple of different ways that we might calculate the percentile. The first method is to count the number of values that are below the indicated value and divide by the total number of values. So for example, if I had 20 values and I put them in numerical order, lowest to highest, and I was looking at one of the values in particular, and 16 out of the rest of the values were below that value, 16 out of the 20, 16 divided by 20, 80%. So the percentile for my value that I was looking at would be the 80th percentile. Method 2 is similar. I count the number of values equal to or below the indicated value and divide by the total number of values. So the only difference here is this equal to part. So that means if there were a bunch of values that were all the same, that could really change what percentile you end up being in, or your value is in, based on just the definition of a percentile here. Now, if you go on to take AP statistics, this method 2 is something that we'll use a lot more. For our class right here, we're just going to actually stick with method 1. It's maybe the simplest of the methods. Method 3 is actually something where it's a little bit more complicated, not a lot, but we basically kind of find a value in between these two. And it's not arbitrary, but we're not going to go through the calculations there because we're not going to worry about it in this class. So again, we're going to focus on method 1. So we're going to count the number of values that are below that value and divide by the total number of values. So let's take a look at this in action. Okay. So here's our histogram of Green Bay Packers player ages again. And I want to know, I've got this question right here. What is the percentile for a player who is 25 years old? Okay. So the easiest way to do that from my table up here, using our definition again, we want to know what percentage of the players then are lower than 25, less than 25 years old. So here's 25 years old. If I want the percentage of players that are less than that, I can actually just highlight those percentages down to 24, and then I can look at my sum of those, which is about 37%, a little bit under 37%. Okay, so we would say that we are in the 37th percentile. So someone who is 25 years old is in the 37th percentile. Now, if we had used the other definition and we had said equal to or below, well, then we would have also needed to include the players that were 25 years old. And then that brings the total up over 50%. Okay? So big difference between 37th percentile and 50th percentile. Again, though, for our purposes, we're just going to look at the values that are below. Okay, so about 37% of all of our values were below the age of 25. So someone who's 25 years old is in the 37th percentile of all Green Bay Packers players. Okay. We can turn this around, and instead of saying what percentile is somebody in, we could say at what age would you be in the 90th percentile. So now that means 90% of players have to be below your age. So if we just start at the top and we just start adding these up, okay, we can see we're getting to 53%, 70%, 80%, around 87%, still 87%, and then here we hit 90%. So at 30 years old, 90% of the players are 30 years or younger. So we would want the next age above that, which is 31. So even though we don't have anybody who is 31 on the Green Bay Packers, somebody who is 31 years old would be in the 90th percentile. Okay? That means 90% of the players on the team would be younger than them. And so that's what a percentile means. Again, what percentage of the values are below the one that you're looking at? Or at what level would you have to be so that 90%, for example, are below you? Okay? We can also, so we use the relative frequency table for that. We could also use our relative frequency histogram for that. We would just go through and we would, add up all the values until we got to 90%. Or if we were looking for the player who's 25 years old, we would just count up the percentages that were below that. So 18.33, 11.67, and 6.67. And then that would give us the percentile for the 25-year-old. Okay? And that's basically all there is to percentiles. We're going to do some more work with percentiles when we talk about normal distributions, and look at how we can use normal distributions to calculate percentiles. But as far as just using histograms and relative frequency histograms, relative frequency tables, that's all we really need for percentiles. I do want to go back and take a quick look at relative frequency histograms again. Just point out one other thing, is we chose classes that were 1 year apart, okay? But I could have grouped Packers into every 2 years. So for example, all the 20 and 21-year-olds together, all the 22 and 23-year-olds together, 24 goes with 25, and so on. So if I do that, instead of 20, 21, 22, I would go 20, 22, 24, 26, 28, 30, 32, 34, 36. Now the oldest Packer was 36, so I'm going to go up one more to 38. And then if I just delete the rest of these, okay, now I look, if I highlight these, they still add up to 100%. So that's still good. But now if I look at these values in here, I can see 22 has 4 people in it. If we go back to our histogram, our original histogram, 22 had 4 people. But 36, this one also has 4 people. Here, 36 only had 2 people. Well, if we come down and look at our relative frequency histogram now, we've got those 4 people are all in this group here. And that's because this 36 gives us the maximum value within the group. So the group before it was 34. That means that this group of 36 is actually 35 and 36-year-olds. And if we look at our table over here, the number of 35 and 36-year-olds is 4. Okay? This group of 34 right above is actually 33 to 34. And there's one of those. So there isn't anybody who's 34 years old, but we still have one person in that group because now we're doing 2 years per group. 33 to 34 here. So notice this number here is the maximum value within the group. Okay, so this one ends at 20. This one goes from 21 to 22, 23 to 24, 25 to 26, and so on. And you could change those frequencies to other values. I could go up by 4s if I wanted to. 24, 28, 32, 36, 40. Okay, and delete the rest of these. Notice this histogram doesn't tell us much because we only have 4 bars. But now we'd be saying, all right, 32 is the maximum here. So this last one is going from 33 to 36. And from 33 to 36, there are 5 people. Okay? I just want you to be aware of that in case you're making a histogram where you're not just going up by 1s on the x-axis like we were here. Okay? So that's for a relative frequency histogram. Just to recap percentiles real quick, remember for our purposes, we're going to count a percentile as the percentage of values that are below a specific value, an indicated value that you're looking for. Okay. All right. In our next video, we will look at normal distributions.